5, 4, 3, 2, 1. We are now full screen. Okay, let's see how long this takes. Okay, this is my lightning talk. I'm Phil Vaz. I go by Phil Vaz online. It's philvaz.com or philvaz@philvaz.com is the email and the site you'll see next. But the title of this talk is porting or converting. It's the term for converting a Windows or Win32 game to Android. And these are the 3 games that I made a while ago. Actually, I made these about 10 years ago. So I was getting into Windows game stuff around in the early 2000s. I started to see these books coming out, particularly by an author named Lamoth. So I decided, what the heck, I used to do this for me in high school about 20 years ago on the old Apple Commodore, but I never really tried it in Windows. I was sort of out of computers a bit in the 90s. I didn't really program all that much, except at work. I was doing some COBOL and stuff like that. This is like pre-web and some clerical stuff. Anyway, so I made these 3 games in about 2003. While I was in the middle of getting my degree in computer science, finally getting it at USF. So I made a Breakout, and that's full screen, but it's not double buffer, so it's got some flicker, and that's in GDI. I made that like over a weekend. It took about several months to read how to do the graphics in Windows. I knew C and C++ fairly well already, but I didn't know how to do graphics in Windows, so I had to look that up with the help of Lamoth. So the Breakout game I made in about over a weekend. The Asteroids game, I call it Vasteroids, V-A-Z-T-E-R-O-I-T-S, Vasteroids. I made it in about a month. And it's just like the classic game, except it's a little faster paced. I like the faster pace. It's got two UFOs, one that always fires at you. Actually, I make them both fire at you if you select hard mode. So that makes it difficult. They always fire directly at you in hard mode. And it's the same thing. It starts with 4 rocks, and the 4 rocks become 8 rocks, the 8 rocks become 12 rocks, something like that. Green, red, and blue on all 3 games. Those are the 3 colors I use. And then the third one I made is a Pac-Man with 3 different types of mazes. This one took about 3 months. I did the little bitmap graphics myself, did everything myself, all 3 of these games. It's got a little AI. I had to figure that out. How to make the ghosts chase you when you're not blinking, when you don't have the what they call the power pellet. When you eat the power pellet, they got to run away from you. So I had to figure that out. And they had to make the eyes bounce back to the jail in the center, what they call the jail. There's some small bugs in the game where the eyes get stuck and they bounce back and forth and they don't make it back to the jail. But anyway, that game took about 3 months. I did all 3 of these in GDI, what's called GDI, which is an old Windows graphics device interface from 2000. Actually, it was Windows 3. They go back to Windows, so old Windows 3. It works in Windows 95, 98. And in 2003, I guess I was doing these mainly in Windows 98. I think we had a couple computers at the office where I was working had Windows XP. But mainly these were compiled in Windows 98, and the games still all compile in the latest version of Windows. So Microsoft did a good job there making stuff, previous stuff compatible. So I can recompile all these in Windows Visual Studio 2012 is the latest, I think. All right, so those are the 3 games I've made. The middle one, Vasteroids, is the one I'm going to try to convert to Android. It's going to be a bigger game too. It's not going to be a single screen. These are all single screen. It's going to be where the ship scrolls and everything scrolls around it. So it's going to be a lot bigger area, sort of wide open, but still 2D. Okay, next slide. And who am I? Okay, who am I? It's Phil Vaz. VazGames.com is my website, where I have the apps and games I'm working on. And I'm actually working in Android and iOS at the same time. I'm trying to learn them both. So it's kind of slow going. I'm not putting enough time in probably. But who am I? I have 10 plus years of web development, mainly in PHP and some ASP.NET C#. I have a Bachelor of Science in Computer Science from USF. Finally got that in 2003. And here's how old I am. I'm old enough to remember the original arcade game. So I was 14 in 1980. So that tells you how old I am. I was 14 in 1980. I'm 48 now. 48, sorry. I dabbled in making video games back in high school and a little bit after in the 1980s, mainly on the Apple II. So we're talking BASIC. So that was often Apple BASIC, which was often too slow. I mean, it drove me nuts how the speed just was never there in some of the games. Some of the games I made for the Apple, I actually submitted to a magazine called Creative Computing. If people remember that, the Byte's been around. Byte magazine's been around forever, but there was a magazine called Creative Computing, not Creative Loafing, but Creative Computing. And I got a rejection letter. This is when I was 15 or 16, anyway. It says the letter says something like, "It did not take advantage of the full capability of the machine," which bottom line means I didn't write them in assembly language. So, and I had games for the Apple II written in assembly, and wow, they were fast, and so that made me want to try to learn. I was trying to learn 6502 assembly language. Like by the time I was a senior in high school, I was trying to learn that, but I never made a complete game in it. But I got into that underlying what they call machine code or assembly code. It was called -151 on the Apple, and then you would get a prompt, an asterisk prompt, and you could see all the hexadecimal stuff. So I learned hex and binary hex conversion, octal later, I guess. So I knew all this stuff in high school 30 years ago, 25 years ago. And I'm trying to make some games on the Commodore VIC and C64, or mainly the Commodore VIC-20. That's the computer we owned. Their cousins had C64. And it had a lot more colors and a lot more interesting stuff. So the games in BASIC weren't that slow. They ran fairly well. So you only had a couple K of memory to work with. That was fun anyway. So I was in 1980. So I got some game programming. By the end of the 80s, I was pretty much out of game, and I wasn't really programming that much. I was trying to get my degree, so I was taking some courses in USF and etc. For financial reasons, I had to drop out anyway. So I was out of it most of the 90s. I wasn't really into the gaming scene. So I wasn't paying attention. I guess there was no internet. I wasn't on the internet, so, and I wasn't going to school. So I sort of missed the whole Doom Quake era. It seems hard to do, but didn't pay attention to it. I heard about it somewhat, and sometime in the 90s when I was on the bulletin boards, but not for games. I was on the bulletin boards for discussions of other subjects, and someone mentioned these games, and I said, "Wow, okay." And someone gave me actually a copy of Quake, I think, to try and run. I couldn't run it. I had an old IBM PC. It wouldn't run it proper or whatever. So I was out of it most of the 90s. And by 2000, I was in the bookstores, like in 2000, 2001, seeing these books for how to program games on Windows. I said, "Oh, okay, I might try that." By this point, I had a Windows 98 computer. So I got some book. I bought the book by Lamoth. It seemed appeared to be the best one, and it still holds up today. I got it in 2001 or so, 2002. It was a 1999 book called Tricks of the Windows Game Programming Gurus. I'll show the title at the end, by Andre Lamoth. And that book showed me how to do Windows graphics, basically in GDI, and also in what's called Direct Draw, which is not relevant anymore, but you can still use it. It still works. So in other words, all the games I made, there was one, the Pac-Man I made first in GDI at 30 frames a second, then I made it in Direct Draw, and it was able to run at 60 frames a second. So Direct Draw is done away with by Windows as of DirectX 7 was the last version of Direct Draw, but DirectX 8 incorporated Direct Draw in Direct 3D. So you would do the 2D just like an OpenGL. You could do 2D and 3D. In Direct 3D, you can do both 2D and 3D. Now the latest thing is a Direct 2D. They have a Direct 2D now. Came out with Windows 8. So that's how you program sprite games, bitmap graphics that are 2D. And then I made some small Windows games, as you saw, those three. I said below, I meant the previous page. Anyway, I made an OpenGL tank OpenGL game. It's all there at vazgames.com, actually /retro. So you go vazgames.com, near the bottom there's a link that says retro games, and that's all my like the demos, that's the examples I did in GDI, learning this stuff, DDI, direct draw, like just direct 3D, just the setup code for that, and an OpenGL game and world and stuff. It was about a year or more of doing that. And then, let's see, there was some times where I tried to make other games. I was trying to make a tennis game. That was a failure, and I couldn't get the players. So I sort of gave up gaming again, I guess, after I have those 3 games. Actually, I took a class at St. Pete College in 2006. It was the first game programming course they had there. And I thought I knew more than the instructor. There was only about 6 or 7 people in the class. One guy had graduated from Full Sail, so he already had a lot of knowledge, and he was into his project was a side scroller. He showed me. It was pretty cool, side scrolling game. And I made a Frogger for that class. I was in GDI, so that was the last game I made in 2006. So I say 10 years later, from 2003, those 3 games you saw to now, 2014. I decided to redabble with Android. So now I'm trying to maybe port those old games or make some new ones. And I formed a company. I had the domain name Vaz Games for 10 years. I've had it since 2003. And so Vaz Games was taken, so the company is Vaz Software LLC. So I took that last year as a legit LLC. And you'll see that in Android and iOS if I ever show up there in the app stores. It'll say Vaz Software or Vaz Games. It might say that too. Okay, next slide. Okay, so this talk is porting or converting a Windows Win32 game to Android. There's going to be 2 parts to this. Hopefully I can keep this within 15 minutes. Oh, already over 15 minutes. Okay. Part 1 is game programming in Win32. That's with C and C++. Mainly C for me. I'm not really an object-oriented guy, although. So it's a struggle learning Java anyway, but I do know some C# and I know some object-oriented PHP, but I'm mainly a procedural programmer from way back, so that's the way I program functions, structs, variables, and it's just straight down, solving the problem, not designing any modules or classes or anything like that. That's just the way I think procedurally. I'm trying to convert myself for this stuff because Android and both iOS and Android are object-oriented, so Objective-C and Java for Android. Anyway, so game programming Win32, your options for graphics basically. Once you know the C++, and I'll show you a little bit of Win32 what that means. Instead of int main or void main, you have a void, or not void, but you have a return thing and return type, and then win main. So it's win main is where Win32 programs start in Windows. And your options for graphics there are GDI, and if you don't use GDI, which is slower, and I thought it wasn't graphic accelerated, it wasn't hardware accelerated, but it is. GDI, I think it's GDI Plus, or GDI by itself, is hardware accelerated as of Windows XP. So Windows XP was hardware accelerated, and it's even better now, better performance in Windows 7, Windows 8. So still around, still used, and you can use it for games. And it's just as fast, really. If you don't have a zillion objects on the screen in 2D, you might as well go with GDI. It's simpler to set up and simpler commands, things like that. So there's also direct. Now, direct draw is not relevant anymore, but I put it there because that's what I made the Pac-Man game in the second time. I made them all in GDI first, and then I made the Pac-Man game again like a couple months or a year later in direct draw. And then there's Direct 3D, it's still around. And as I said, there's now Direct 2D for Windows 8. So that's the way you'd want to make 2D like side-scrolling type stuff in Windows. And then there's OpenGL available for Windows too. And I made an OpenGL Windows tank game called Vaz Tank. It's sort of like the old Battlezone, with 3D models, but the models aren't textured, so they're just very plain green-looking. Very plain. The cubes and the pyramids are textured. Those are the objects that you're sort of navigating around, fighting against other tanks. It came out all right. Anyway, so in game programming in Android, your options are Canvas, which is a 2D drawing thing. Now, Android, I'm still struggling to learn the code, so I just have the system's more conceptual thing when I talk about the Android stuff. I don't have actual code. I have code in the books, of course, and examples. I have other games downloaded, but I don't have it. I don't have my own Android, say, framework yet. What do you want to call it? A set of code that I'd be using game after game, but like I have in Windows for Win32. Anyway, so your options are Canvas, which is 2D, and then you can use OpenGL in Android. And it's OpenGL ES for embedded. I guess it stands for embedded systems. So it's a it's a full 2D and 3D hardware accelerated graphic. Some people call it a graphic engine or game engine. OpenGL is not a game engine. OpenGL is a game framework, I guess you'd call it, or a game library from which you can make a game engine. You can make a 3D engine from OpenGL. And the other option is to use a actual, fully tested game engine out there. And the big one is Unity 3D, and you can also do 2D in it. There's another one I don't list here, but I list at the end called AND engine. That's for 2D games in Android. So, and those are both using, I assume they're using OpenGL. So you can go the hard route and learn OpenGL yourself. But your game probably won't look. If you want to do a professional, really professional game that looks that compete with the stuff that's out there by the big companies, you would use something like Unity. If you're going to use OpenGL yourself and learn it, then your game probably is not going to look that great, because it's not going to take advantage of all the the special things that OpenGL gives you, like with the lighting and all that stuff. Not to be too vague, but anyway. So that's the two parts of the talk: game programming Win32, game programming in Android. Next. Okay, so what is a game? What is a game? What is a game in terms of software? It's it's really a system or an architecture that includes many parts. And most programs, if you're making a program, or I say even a website. I've done many website stuff over the years. You'll have this part. You'll have the input. You have some form of input, and then some form of logic that works on the input, and then some form of output. That's it. That's like the minimum for a program. Games are more complex because they usually involve either all of these things or almost all of these things. So you have game logic, which is the logic of the game, and then you have input, and the logic works on the input. It produces output, and that produces graphics. So you got to learn the graphics side, where it's displaying in a particular way, whether in bitmaps or primitives, they're called primitives, or fully 3D stuff using OpenGL or something like that. And then it's got sound music, which is another thing to learn in Android, how to produce sounds, which I'm not sure how to do yet, so I'm learning that. But and they also have a primitive AI or artificial intelligence and some physics. Mine is like the asteroids has some. It's very simple formulas, basically for the rotation, for when you fire a bullet, how to make the bullet path follow along with the direction you're pointing. Those two main things. And also, if a UFO, say, is firing at your ship, the UFO has to know where the ship is and make the bullet from the UFO all follow the path. So it would fire on where you're located. If you move, of course, the bullet's not going to follow you. The bullet's going to continue on the path and miss. So that kind of stuff involves a little bit of trig, a little bit of a squared plus b squared, the square root of, stuff like that to get the distance. There's about 3 or 4 formulas. So, and then some games have network if they're really complex. Networking if you're doing multiplayer, and then a database which is your resources or resource manager for the. I know this is kind of blurry. You can't really read this, but this says what mask? I can't remember what that says. Oh, sorry, music, sounds, textures, 3D models, and other. So your database would include that. Sorry about the quality of this image. It's actually a GIF that I had from. It's a book from about 5-7 years ago. From the people who made GameDev.net anyway, and just the original graphic wasn't that clear. But anyway, okay. So that's what a game. That's what a game is. All these elements, shall we say? All these or objects, all put together, performing at the right the right time, in the right order, and that's it. Okay, next. Now, so I'm talking about game programming in Win32. What is that? And then game programming in Android. How are the differences there? And what are some of the hurdles I'll have to figure out, problems I'll have to figure out in converting from one to the other. So basically, now this is another blurry image, sorry, but what this says is this is the way the Win32 programs, whether they're games or not, work. Although I put the word game in here because this is a game. So what you have is the start, and if you know C and C++, normally the start of your program is main. Or you got int main, you got void main. So void, you're returning nothing. Int, you're returning an integer. But main is a function that starts, where the program starts. In Win32, it's win main. So win main is a function in Windows that tells it this is going to be a Windows program, and it's probably going to have a window. You have to describe the window. Actually, you have to define a class for it and fill in the variables. So it's a bit of setup code. So the idea is there's two main functions for a Win32 program in C and C++. There's win main, which is where the program starts, and then there's win pros, or win procedure. And the purpose of win procedure is to process what's called Windows messages. So in Windows, you have the idea is to have the game run at 30 frames a second. So win main is going to call within it game main, which is all the processing of your game. So from game main, it goes to the game systems. These peak message, translate, dispatch. These are Windows functions that are called to process a message. And what is a message? A message is a thing like, okay, the window has been moved. Window has been moved. Oh, Windows has to repaint. Oh, the person is trying to close the window. Close. Things like that. And like a mouse move, you can read the mouse in Win main, in Win procedure. You can read the message that the mouse is moved, and then you can get the coordinates of the mouse. So those are Windows messages that are not per se part of your game. They're part of the system, part of the Windows, like the window system. Now the thing with a game, of course, there's no X. You're not exiting the window. You can run the game in a window. Lamoth in his book shows how to do that, and then he shows how to go full screen. What he doesn't show, I don't think, he doesn't show how to go full screen in GDI, so I had to figure that out. Anyway, there's a thing called change display settings. So you can go full screen in GDI. He shows how to go full screen in Direct Draw and I think Direct 3D. But you can go full screen in GDI. So the three games are running full screen. So there's no X, there's no minimize. The window is gone. It's completely disappeared. But the win procedure still has to read. Okay, there's no Xing out, but I make it so you read this escape key. You read the escape key, and that will close the game. Automatically closes in one click, and one thing from the keyboard. One X, one escape. Hitting the escape key. It sends it just. I think it's win or message destroy. I forget that it's in the code there, but there's only basically 3 Windows messages you got to worry about. Once you have a full screen, we're talking about a full screen game. There's the opening or the initial of the window. There's when it has to be repainted, and then destroy. So those 3, that's coming up here. I'll show you in the code. But so basically, this is what's called the pump, and this runs at hopefully at least 30 frames a second. In the direct draw version of my pacman, I'm running this at 60 frames a second, so it's nice and smooth. And there's a way, there's code to make it lock in at 30 or 60 frames a second. There's a simple way and a harder way. A simple way, you can do it in a couple lines, where you're forcing it to 30. Where the other ways you can make it run at the maximum speed. But the idea is between 30 and 60 frames. Normally, you can tell it exact number, and then you can have a frame per second counter that will read how many frames a second the game is running. I did that for my tank thing, and it runs consistently at 60, so it's nice and smooth in OpenGL. So that's it. So within this WinPros is actually not only game main, but there's game int and game quit. But game main is the function that's run consistently 30 frames a second. Game int and game quit are called once. game init. So game in, like, in other words, game initialization is called once to initialize all objects in the game, set up the screen, and start the game at the demo mode. That's game init. Game main takes it from there and runs all the rest of the functions in the game until you're ready to quit. So all the objects are created and everything's active basically. Then when you want to quit, you hit escape. It calls game quit. Game quit does the opposite of game init, and it removes all the objects, deletes them. Say deletes, and what's the term? Well, there's pointers, there's handles. In Windows, they're handles. They're H variables, H, WND. Anyway, we'll get that in the code. I can't remember now, but so that's it. So this is game programming Windows. So you got the Windows Win32 pump, and it runs 30 frames to 60 frames a second. Here we go. Now, game programming in Android is similar, where you have you're going to have a loop, some sort of loop. Now as far as code, I don't have enough knowledge here to actually provide code for Android. So I have it in some of the games and stuff that I've downloaded, but I needed to put it all together into my own, so make it my own. So I have, okay, here's the way I do it in Android. I'm still studying the various things on how to go about doing this, but I'm understanding now enough to show you the concept. So this is more conceptual, but basically, as you all know who've done Android stuff, everything revolves around an activity. So an activity is basically you can see it as a screen or an individual UI, an activity with a view. So these are the two diagrams I got out of some website that talked about the game loop in Android. So within an activity, you have the view. The activity is the holder for the view, basically. And view enables a drawing and detection of touch events. And it's touch events, by the way, so it's not going to be mouse or keyboard. It's another issue I have to figure out. There's no input from the keyboard. There are some phones, I guess, with keyboards, but you can't rely on that, as many phones do not have them. So it's going to be touch, and it might only be single touch. Some phones, the older phones, don't have multi-touch, so that's another issue. But okay, like I said, so you have activity view, and then to draw in Android, you're using something called Canvas, which is the 2D API, application programmer interface, provided by Android for drawing various 2D primitives and bitmaps. It's similar to Windows GDI because you have things such as in GDI it's ellipse. You draw ellipse. That's why I draw the UFO. The UFO is two circles, basically two circles, a bigger circle and a smaller circle and a bigger circle. And to draw the ship, it's 4 lines. Dun, 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 dun. So, like the old Star Trek symbol, it's 4 lines. So, in Android and Canvas, you have, I think it's lines or draw lines. You have draw a circle, and you can specify the radius. You can draw, I think you can draw a polygon. I gotta look that up. In the early versions of Canvas, I don't think you could. In GDI, you have polygons, so you can draw, say, a rock with various points. Say 8, I think it's 8 points. My rocks are 8 points, 8 to 12 or something like that. So in GDI you pass in an array of points, XY points, and it draws the polygon really quick. And you can have it draw just the outline, which is what I want. I don't want it to fill in with a color, but I want it to draw just the outline of it. And Canvas, I think, has that. I think it has something called Polygon. I have to look up. But now, if you don't go with Canvas, now the Asteroids game, which is the game I'm talking about converting to Android, can be all done in Canvas because there's no fancy animation. There's no 3D. It's all 2D. So you can do it in Canvas. You can do it in OpenGL also, I guess, but there's no strict OpenGL commands for polygon or line, and I don't think I have to look this up, but OpenGL is mainly for drawing bitmaps and 3D objects, 3D models, and triangles. So Canvas is what we use for primitive stuff like lines, points. And if you don't have too many of those on the screen, then you're good. It should run at 30 frames a second or higher. So that's the difference there. Okay. And it's done in Java, and XML describes the view. It describes like the layout. It's called the layout, and in the Android, what is it? The manifest has a lot of your constants there, stuff that you're accessing or referencing in the game. So it's both Java with XML. Next, okay, this is a more sophisticated, I guess, game loop, or they call it here it's called circle of life. But it's actually the activity circle, or the activity life cycle, or life circle, something like that. Activity life cycle. This is from a company, NVIDIA, who makes a lot of the graphic cards and stuff. They talk about porting. This is in the this graphic is in the context of porting a game from like a high-end 3D graphics game to Android. So here they're talking about the activity cycle, basically the circle. So these are functions that are called. These are similar to Windows functions where you create a window. Here you create an activity, and then there's a function on start, and then you can pause, you can resume, and then you stop and you destroy the activity. It's like destroying the window. So it's similar to Windows messages, I guess you can call them. So these are the functions or methods that had to be overridden on create, on start. All of these can be overridden in the code, so you can keep track of where the pointer or whatever the program. I don't know what the term is. Like the counter, the pointer of the game, where it is in terms of the game, but in terms of execution. So that's basically your circle or your cycle or activity cycle in Android. And that's it. Next. Okay, so these are the issues that, like I said, this is going to be more conceptual because I have code in Win32, which I'll show you coming up here, how I made those 3 games. Basically, they're all made very similar. Breakout, although the Pac-Man is much more complex than the Breakout, they all use the exact same win main, exact same win procedure, and the same setup code in GDI. That doesn't change. The only thing that changes is like when you're adding bitmaps, so you have to, like Pac-Man has a ton more bitmaps. Breakout and Asteroids have no bitmaps actually. So there's the issues have to consider when going from the Win32 Windows game to Android. In Win32, the resolution is just set. Now that's a choice I made. You can have multiple resolutions, but the advantage makes it less confusing in Windows, because I can just say put the screen to 800 by 600. Now it's a temporary change, so it changes the screen to 800 by 600 when the game is run. And so I know exactly how big the screen is, and it's every no matter what monitor, no matter what you had your monitor set at, it'll run at 800 by 600, and it runs. So that just makes it simple, super simple. There's no need for 2, 3, 4 copies of the graphics. There's no need to do any calculations for how big the screen is because it's the same. So it's 800 by 600. Now, when you hit in my games, when you hit escape, it returns back to your original settings. Hopefully, the game doesn't crash, which it won't. It doesn't. It exits properly. It's been well tested. So, if you download them, they're available at VazGame/retro. But you exit and it returns back with change display settings, null, or change display settings 00, something like that. That will return it back to your original. Android, on the other hand, has multiple resolutions. So multiple meaning. And there's a paper I have showing the various sizes here. There's actually 4. I think I mentioned 3: small, medium, large. It's actually small, normal. It's called small, normal, and large and extra large. So anything from 2,000 across to 1280 across to this is landscape mode. When I say 1280 by 720. And then the original phones had 320 by 240, which are tiny. Those are the ones that the original Android, like maybe 1.5 or 2.0. So there's at least 3 or 4 different sizes you have to deal with. If you want your game to look good and run on as many Android devices as you can, you specify in the manifest actually here's the resolutions that the game will run at. And you can make, as far as I understand, you can have Android scale it for you the graphics. But if you want the graphic to not blur, if you want it to look clear and all the rest of it, then you would repaint it, redo it yourself. So it's a bit more work. But you might have 4 versions of the graphic, like the Pac-Man game might have 4 versions of the ghost, 4 versions of the, there's actually 2 animations for the ghost, so that's 8. So 4 times 2 is 8 times 4 is how many graphics you need for just the ghost. Same with the Pac-Man thing. Same with all the bitmap graphics. There's 4 copies of them for the 4 resolutions. Okay, the other issue is input. All my games I'm using basically control is fire. I have the arrow keys are like the left and right are the rotate, and up arrow is thrust. So control is fire. So that's it. Escape is exit the game. In the Pac-Man the same. You can use WASD also. In the tank game I'm reading the mouse, so I read the mouse. Oh yeah, in the breakout game I read the mouse. I read the mouse for the moving the paddle, or you can use the arrow keys at the same time. It seems to work better with the mouse. The mouse is immediate. The arrow keys you're moving, and then it moves it moves at a certain speed, and you hit the left arrow and hit the right arrow. So it's not as easy. It's easier with the mouse in the breakout, but. So that's an issue. Now, Android, some of the earlier phones don't even have multi-touch. They only have single. In other words, you can't have 2 buttons and requiring them to be pressed at the same time. So you could make the game, I think the Asteroids game would work like that, though you just wouldn't be able to rotate and thrust at the same time. You could thrust, and then it would thrust a little bit, and then you could rotate. So you would normally put the area to be pressed on the screen, somewhere on the bottom left, bottom right, or something like that, out of the way of the gameplay, so it's not in the way. So that's an issue to think about. There's no keyboard, no mouse in Android. Now, those are 2 sort of disadvantages and hurdles for Android you have to overcome. But in terms of code, I'm pretty sure there's going to be a lot less code in Android. So, in other words, the Asteroids game, pretty much all done in C, C++. There's some .h and there's one file called .rc. These are for the resources, but everything's done in code. So, including menu, if there's any menus, if there's any visual stuff. There's no really UI per se in Asteroids. It's just the whole game. But I do have text displayed, and that's all done in code. So extra lines, in other words. And the Asteroids game is about 2,000 lines plus of code. I would assume the Android is going to be less than that. The full code of the Android, and it's all done in one file too. I just kept it simple, although it was kind of hard to, if you have everything in one file, you got to try and find it. But 2,000 lines is not that long, so 2,000 lines of code. The Pac-Man is actually about 3,000 lines. The breakout is about 800 lines. So 800 lines for the breakout, 2,000 lines for the Asteroids, and 3,000 lines for the Pac-Man. All procedural, no classes. I did it as simply as I could. In my opinion, I mean, there's no because object-oriented code is sometimes hard to read. Sometimes it's more obscure than procedural, in my opinion. Depending how if you label your variables clearly, then it's not that cryptic. But so those are things I got to consider, solve, and consider. Next, okay, this is the actual game in Win32. So I took the Asteroids game, divided it into 4 parts. Took out a lot of code. I put ... So this is the bare sort of skeleton version of the game. I don't know if you can see this, but the first line in any game that's going to go full screen is, and you're not going to use any what's called MFC, Microsoft Foundation classes. If you're not going to have any complex user interface, which I don't, you do this, which cuts down the size of your executable and all the extras, the overhead that would go in there. You say number defined Win32 lean and mean. So Win32 lean and mean. So that makes your executable tiny, basically. It cuts out everything. It gives you what you need in Win32, but none of that extra stuff that you don't need. Okay, and then there's going to be one included of Asteroids H. That includes sounds and icon resources. So this is basically a straight C style, and it's following Lamoth's book. So the style that he did at the end of the book, it's a 1,000-page book. At the very end, he does a full listing, and he shows you he's doing it in direct draw. I end up doing it because he has a lot of GDI examples, so I do it all in GDI, which is simpler than a direct draw. The order is GDI is the simplest as far as the least amount of setup code. Direct draw is a little bit harder, and then of course direct 3D is a little bit harder than that, so it's a little bit more setup. But it's all within 1,500 lines of setup, so GDI is less than probably 20, 25 lines of setup. But okay, so it follows Lamoth's style, at least his order of things. And this is the way most C programs, not C++, but straight C programs work. So, sorry, you have your includes. First, you have in order to find Win32 lean and mean. That's for Win32 or Windows to cut out all the extra. Then you have all your includes, and then you have all your defines, and then there's macros. There's one macro that I use, which is for key up, key down. It turns the key up and key down function into you can just read any key on the keyboard. Key up with a number, and the number is the ASCII value for that code. So escape, I think, is 27. So you say if key up, or if key down, if key down 27, then that means true. True, you're pressing that key. So it's a macro using async key state. Async key state to read async key state. So it turns that Windows function into a simple key up with an ASCII value. And then globals, I use globals because it makes it easier. You're not passing. Now I don't use globals all throughout, but I use globals for about 7 things that need to be known all throughout the code. So I don't have to pass them in the function. It does make the thing faster. From what I understand, it makes the game faster if you use globals. Although you got to be careful with globals because you don't want to name them uniquely enough so it doesn't get confused with any local variables. So, which I do. So it's really simple to I keep it from confusion with the globals. This is the way Lamoth did it, and I like how it just makes things easier. You don't have to pass these things every time you're calling a function. So now this is the slightly confusing part, but these are all the variables that are needed in Windows, basically Win32 for graphics, graphics and/or just for a Windows game. You need a handle to a window, so I call it game window, and they're all set at null at the beginning. You need a handle to the instance of the app or instance of the game. So I call that game instance. Game underscore instance is an H instance. Now this is for GDI only. You need a handle to the device context. Your device context might be equivalent in Android to your activity view, to view/view. That's your device context. It calls it DC, HDT. So I call it game DC. So I handle the device context. That's for drawing stuff to the screen. Those are those 3. So and then you need now I'm doing as Lamoth does in his game. You have what's called a back buffer, a double buffer. So this is a double buffering is a technique that was known. I don't know. It was known in the 80s, I guess, for removing flicker. So the idea is if you don't use a double buffer, if you're just writing right to the screen, you're writing to the screen all the objects, every frame, every time the game runs, you're moving everything a little bit at a time. You will see flicker. You'll see artifacts and various. It will not look good. So it's not. It won't be smooth. It will be smooth. You might see a little shadow or whatever, but there'll be flicker all throughout. Not too much. I mean, the breakout game I have, with only the ball is moving in your paddle, so there's not much movement, ball and paddle, and there isn't that much flicker. There is some, you can tell, but that one does not use a double buffer, so there's no back or double buffer in that one. It's just single drawing right to the screen. The idea of the double buffer is it makes a copy of the screen, so the screen is off view. It's not shown to the user, and this happens 30 times a second, so we're talking really quickly. But the stuff is all your objects are off screen. It's a copy of the screen. You move, you display everything on the off screen. You move them off screen, so everything has to be moved. Okay, you move this pacman a little bit that way, or this ship, you rotate it slightly. Move all the objects. It happens, super fast. And then once everything is moved, you flip So you swap the back buffer to the front. So all the objects in the back screen suddenly become the front screen. So there's no flicker. It just completely reverses the. Basically, I guess it works with a memory. It's just a pointer swap. So suddenly now the front buffer is the back buffer, and the back buffer is the front buffer. So it swaps back and forth 30 times a second actually, or 60 times a second if you're doing 60 frames a second. So you have no flicker. So you draw. The idea is to draw everything to the back buffer, the thing that's not shown on screen, and that's a technique that goes back to like I said, the 80s with the side scrollers and everything. This is where they were done to remove flicker. So and then there's one other variable. Okay, these are for the back buffer. So you have a back DC instead of a game DC, HDC. They're both HDC. This is a copy of the game screen basically, or the device context is called Windows, set to null. So that's for the back buffer. This is a bitmap for drawing a back bitmap because it's only drawn to the back. So I don't need a front one. So I only need the back one. So back BMP. And then you have this is for, I guess, the older, can't remember what that's used for anyway, but that's for an older copy, I guess. I got this, so I have an old and a current one. And then this is the size of your window for the back buffer. It's just the size of the 0. 0 is your top left. In Windows, it's always, it's top left. Well, in X top left, Y top left, and then X bottom right, Y bottom right. That's your rectangle. So it's just giving the size, and it's set as a constant. This window width and window's height is set inside the number defines up here. So this is 800 by 600. I set it here. I put the variable here so you can just refer to it as window width, window height, and that's set. You know that these constants show up throughout a couple times. Window width, window height. But the number 800 by 600 is set in number define. So, and there's one other variable for full screen mode in GDI. I had to do something called dev mode. This one I had to look up. So I was asking at gamedev.net what the variables for this is, and it's called dev mode. So dev mode sets up your full screen GDI, and I just call that game screen. So it's a screen. So I have game window, game instance, game DC, and then game screen, and then these other ones are for the back buffer. And then I took out some stuff here, but there's pens and brushes in Windows. This is for your colors. If there's a green, red, and blue colors I'm using for the outline of the asteroids, for the points, for the ship, and the UFO is white and the ship's white. But that's for colors. And I also make it, this was after I made the game, about a year, 6 months later, I figured out how to use a joystick. So I added joystick code to it. So it works with the old Microsoft Sidewinder and just small joysticks that have just typical 4 buttons and 4 directional things and 2 target, and that's all you need. And the global game variables, like there's a bunch of those, like I don't know, many of them. Score, how many ships are left, how many rocks are left to shoot. There's about 15 of those or so. Okay, and then and this is an important one too. Game state. So this is how I keep track of in Windows where the game is. So you started at game demo init. It's basically game demo init, then game demo live. Wait, how do I say that? Wait, let me see here. Hold on. Oh, run. Sorry, run. So it's game state demo init, demo run. So that means demo is now running. Game init means a game is about to run. Game init is initializing the game stuff. Game run means the game is running. And then game pause means the whole screen is paused. You hit the P key. The P key, it reads the P key and it pauses the game. And then there's game restart. When it exits the level and it's about to restart, it resets some things, and that makes it go back to game init and then game run again. So this state is kept track of inside a game main. I'll show you. There's a switch statement, switch game state, And then from there, it figures out, okay, is it case demo init? Then do this. If it's case demo run, do this. If it's case demo game init, do this. Game run, do this. Game pause, game reset, and that's it. Game quit is just the escape key, so you don't need a game quit. You hit the escape, it reads the escape inside that win pros right before it calls the game main, and it will destroy the window, and the game is exited, and safely delete all bitmaps and all pointers, basically Windows pointers. Okay, so that was part 1. Part 2 is the structs for the game. So you got objects, functions for gameplay. I'm going to have to talk a lot longer, I think, a lot shorter, a lot faster. This is taking way too long. But so typedef struct is all my structs. So I have one for the asteroids. I define the struct for the asteroids, and I set rocks to max asteroids. So there's no I'm not using any link lists or anything like that. I could. I mean, I had computer science. I know about link lists, but I just use simple for I equals 0 to max for all the stuff. And then so you're going through now it could be less efficient if you have a billion objects, yeah, but if you have just 12, or 40, at the most I think we have is it about 50 rocks if you split all the big ones into 2 and split the medium one into 2, and you have only small ones. I think the most you have is about 40. So it's going from I0 to 40 or I0 to 39. And it checks if rock is alive. So part of the struct is a variable called alive. So rocks parentheses 0 dot alive. If alive, then do it. If it's not alive, then it's not active. So, and we'll talk about that. So, well, we don't have to talk about it actually. But there's a function for insert rocks, so it inserts it inside the array somewhere. So that's all I do, from 0 to max constantly. Fix 60 times a second. It can do it really quickly. So that's it. So there's a struct for the asteroids. There's one struct, an array struct basically for rocks. So I call them rocks. There's one struct for the ship. The ship is the rotation position, the XY on the ship, how fast it's going, and I do a slow. It has a little bit of physics where it slows it down. So there's a little deceleration, there's an acceleration variable. So it's very simple physics. And then there's the bullets you're firing. It allows up to 4 bullets at once. There's a struct for the UFO, a single UFO at one time. There's only one UFO on the screen at one time, keeps it simple. I'm redoing the game where there's multiple UFOs, so you can have up to 10, but the area is so large that most of them are off screen. But you can hear them anyway. You can hear their sound. And then the particles. The particles just adds a little bit of explosions to the screens, explosions to the gameplay. So when you hit a rock, it explodes with a couple particles, which are dots. A particle is a single dot. There's no complexity about them. In some games, particles are like an object with a texture on it. Like if you have flames, if you have explosions with debris. That's much more sophisticated. My particle is a single dot, the white color, I think, white color. So no, it's the color of the no, I think it's just white. Yeah, it's white. So you hit the rock, a couple particles go out. I use particles for the when you thrust. I randomly throw out particles beneath the ship, so it looks like a thrust. Cool. And then when you get hit and you exploded, the particles go out full. So it fills up the whole screen. So that's particles, and it just keeps track of all those. So all this has to be done, keep track of 30 frames a second. So move all the particles once, move the UFO once, move each of the asteroids once, 30 times a second. So these are there's the structs, okay, and then the next we have functions. So functions are the three main ones, like I said, are game init. Aside from the Win32 ones, remember WinPros, WinMain, and WinPros. The game starts in WinMain. Once it's in WinMain, it's calling these. So it calls game init once at the very beginning, only one time. That's it. Set up full screen, initialize all the objects. It takes a split second, of course, but it's slow. I mean, it is slow in terms of in terms of overall speed. It's got to set up all those pointers, and but it's only done once, so you don't even notice it. It takes like a half second or something. Then it goes from there, goes to game main. Now game main is the main function of the game, which does the state. What state is it in? Demo, running, reset, or pause, and reset. Those four. And actually, there's init, and run for our demo and running. Anyway, so that is called 30 times a second or 60 frames a second, and it handles all the processing of the game. So within the game main, in game main calls all the other functions like set rocks, move rocks, set ship, move ship, insert particles, move particles, and and sound in it, sound in it, sound quit, and then the sounds are played in various points of the game, depending. So there's that. Okay, and then game quit is the opposite of game in it. Game quit closes all the what they call cleans up. So it closes all the pointers that were set, including the Windows stuff and the game stuff. There's no pointers in the game really. There's just pointers in the handles and Windows. So, they call the H-Wind and all those, and it does it in the reverse order just to be safe. It closes the pointers that you set in reverse order, and then the last one is the first one you had set. So it closes them in that just to be safe. That probably doesn't matter too much, but Lamont suggests doing it in the reverse order, and then it goes back to the game exits, and it goes back to your normal display, and hopefully nothing's corrupted in Windows. I haven't noticed anything, so game runs good. All three games run good. Okay, next. Then part 3 is, like I said, the Windows. Here's the actual Windows functions: WinPros and WinMain. Win32 functions. Every Win32 game or program, every Win32 program has these two at least: a WinPros and a WinMain. So everything starts in WinMain. For some reason, this one's down here, but anyway, WinMain is first, called first, and it returns WinAPI. So it returns an int, but WinMain is a WinAPI variable. That's a callback, I guess. I'm not sure. WinProcedure is a callback variable type called callback, and L results. See, this is stuff you look up in either Lamoth will explain it. The other best source for Win32 programming, like the Bible of Win32, is a guy named Petzold, Charles Petzold. For years, it was his 1999 edition or 1998 edition of programming Windows. Programming Windows, I think it's called, or Windows. No, it's Programming Windows. So it covered basically on Windows 98. He didn't update it for XP. He didn't update it for Vista. He didn't update it for 7. In Windows 8, he had to update it because of so many changes have gone on. So now he includes a Windows 8 version. It came out last year, so after 15 years. So it came out in 98, the first version of it. It's still considered relevant. That book's still considered relevant for all Windows programming up until Windows 8. Now Windows 8 has some changes, some major changes. So he created a Windows 8 version. So it's programming Windows 8 with, I think it's with C# and XAML or something like XAML is the latest version of his Petzold's Windows book. But if you want to know everything about Win32, go to Petzold. Lamoth's books, which I'll show you at the end, go enough into here for games. So it talks about like these three. This is your Win procedure. That whenever there's a message, Windows message has to be received, such as, okay, a Windows created, do this. So you have, and this is all I have for my game. All you need. Lamoth suggested this is all you need, and it works for all the games I've used in Windows. So you have to have a WM create. That's the case. So that translates to a code. But when the window is first created, do something, and there's a couple lines of code for that. When the window needs to be repainted, like if you have, now we're in full screen, so not necessarily repainting going on, but if you had a window and something goes on top of it, and then you remove the other window, then it has to be the previous one has to be repainted. So stuff like that. This destroy is for when the window's being closed. When you hit escape on my thing, either hit the X in the window or you hit the escape on a full screen, then the window has to be destroyed. So that's red here, and that takes care of the code for basically exiting the function, exiting the application. Sorry, exiting the application. And then you got your win main is this is important. H instance is defined here. Then H previous instance is sort of a throwback to the earlier versions of Windows I was reading. And then you got some command line stuff, and I don't know, something about command show. I gotta look at what that one is, but these are called, I think this is 0 here, and this is 0, and this is null, but this is the main one. This might have something, but these are all null or 0, I think, and this is the main one that's returned, and you save it. Here's where I save this in game instance. Now game instance is used throughout the program whenever you got a call, something having to do with the Win32 function. So, and then the Win class is defines the window itself, which is full screen. You define it as full. You can define it as a full screen, not windowed, but full screen. The size of the window and all that stuff. The generic window handle, generic message. Okay. So that's it for the Win32 stuff. Next, and then following after the Win32, those two functions, win main, win pros, are all the game functions. The main three are game init, game main, and game quit. All three of my games have at least game init, game main, game quit. Within game main, and I explained, game init is called once and does all the initialization. Game quit is called once at the very end when you hit escape. It's called once, and it removes all the pointers and stuff. The opposite of game quit, and it does in reverse order. Game main is the workhorse of the game. It's running 30 frames a second, 60 frames a second. Within this switch game state. Game state is basically 0, 1, 2, 3, 4, 5, 6. So there's 0, and that's in the number defines. It's defined and defined. But I use a what they call a constant, uppercase. That's for classic C. You do that. Uppercase means this is a define, or they call it a token. So I can reference it instead of having to remember, okay, was game init 2 or 3? You just call it game init, game state, game init, and the number is defined in the define. So when you have number defined, game state, game init is 2. So that's defined at the very top in the defines in part 1 of the code. So these are called, these are referenced throughout the code. So I don't have to remember the numbers, and that's why it's done like that. But anyway, so actually there's space inside here. So inside game init, demo init, a couple of functions are called that are below these. In demo run, a couple of functions are called like set rocks, move rocks. In the demo, there's no ship. It's just the rocks moving. So there's no set ship and move ship. In the game init, there's set ship. In the game run, there's move ship. In the game init, there's set rocks. And also in game reset, there's set rocks. And game run and move rocks. So the move rocks, move UFO, set UFO move. All right, set UFO has occurred randomly, so that's not in the game state here. But okay, so that's all that, and then the game quit is called 1. There we go. Okay, now I guess I'm done with the talk pretty much. And here's the sources. There's my sources I was talking about. Andre Lamoth's Tricks of the Windows Game Programming Gurus from 1999 is still probably the best, although it's very Windows-centric. It's the best 2D game programming book for like the fundamentals of 2D games, the math involved, but it's all Windows stuff throughout. So you see a lot of and it's actually outdated Windows stuff, but it's still a good, probably the best source for 2D games because it's so complete, it's so comprehensive. Like Petzold for Windows itself, Win32. Lamoth for games, this book is 1,000 pages, so it covers everything. Just like Petzold's book was, I think, 1,000 pages. Now this book on the right is the updated version, so it's a new cover. I have the original book. See, the original book. And it's weird, in the original book it says Fundamentals of 2D and 3D Game Programming. There's actually no 3D game programming in the book. The 3D stuff is included on a CD that you get with the book in PDFs or text files or whatever. So the 3D articles the game is about 2D game programming. So that's why he doesn't include 2D and 3D, because this book is the same as this book, except it's updated to DirectX 8. So he talks about how Direct Draw has now gone away, because this book is basically DirectX 6. And by 2002, Microsoft had released DirectX 8. 7 was the last DirectX that included Direct Draw. So you can still use Direct Draw. In fact, I'm using Direct Draw 1. I'm using Direct Draw 1 and it works fine. So Direct Draw 2, 3, 4, 4 they require extra numbers, and I don't know. So I just went with Direct Draw, the Direct Draw function, and they all work. So no problem. Except the only issue is in Direct Draw 1, it's probably because I'm using Direct Draw 1, it doesn't work in Windows 8. So like the executable, once I compiled it in Windows 7 even, runs fine in Windows 7. When I run the executable in Windows 8, it's too slow. Something's going on. So something's I haven't been able to figure out, but it's running at like 2 frames a second. So something's screwed up there. But it works in Windows 7 and before. So I created it and I compiled these in Windows 98, and they all work then. Worked in XP, Vista, 7. So they're all fine as far as 2D. GDI, in fact, runs fine in Windows 8. So you can run GDI all the way through all the Windows if you stick with GDI, which I did, and then I added Direct Draw later. But so that's Andre Lamothe, The Tricks of the Windows Game Programming Gurus, first and second edition, 1999 and 2002. These are books. Now, the second one, actually, I wouldn't recommend so much as I've gone through it now. It's very old. I mean, it's although I said Lamothe is 15 years old, but that's still relevant because of the concepts in the book. These are more specific to Android, and since Android is changing so much, this has changed. This book is better, more relevant. Beginning Android games. It's 3 years out of date, but it's this one has a lot of, like, there's Linux command line stuff in it. There's stuff that doesn't need to be there, because I guess it was more difficult to install the API or something. I don't know. But now Google gives it to you in a single install, where you got both the Java stuff plus the the SDK all included in one with Eclipse. With Eclipse itself, is all one single installer. So I recommend this book over that. I mean, the 8-press books are very good books. So the book was probably very relevant maybe in 2009, but that's 5 years ago now. So I wouldn't necessarily get that. But the book on the left is still good. I don't have that book, Pro Android Games, as I didn't buy that. I have it as a PDF. I found it online. Oops, I found it online for free. But it's not as good as this is the better book. The Beginning Android Games. I would stick with that. Because both the books are sort of beginner books, or pro books. Even though it says Beginning Android Games, it covers OpenGL, it covers 3D stuff in the second half. So it's covering advanced stuff for games. Both the books cover pretty much similar material. Maybe the pro one assumes you know more. It says assumes you know, but it starts out with the asteroids. It's talking about Space Blaster, so that's sort of a 2D shooter like Galaga or something. Galaga, Galaxian, remember those games? And Asteroids is the classic Asteroids game. And then it's talking about Doom and Wolfenstein, 3D stuff from id in the 90s. It's talking about porting those to Android, so it does port them. It shows a lot of changes that have to be made, but this is the better book as far as organization, as far as the concepts and staying relevant. So I would stick with Beginning Android Games. Next, okay, this is my last frame, and basically here's the websites. I fit a couple on here. I could have fit more if I did smaller type, but websites, some game engines, and the professional game developers you can learn a lot from. I'm vazgames.com. The official Google site is, of course, developer.android.com. That's for Google Android. The official Play Store, play.google.com/store is what it directs you to. And then the MSDN, if you wanted to learn about Microsoft game development, the current site is msdn.microsoft.com/ and then it's games-development-msdn. The game engines I mentioned, if you want a really professional looking game, you don't want to try and do it all, learn it all, and learn all you need to do, learn in OpenGL, which can be complex, then just stick with the game engine and learn the functions in the game engine, which will call the OpenGL for you. But it tells you how to prepare the assets and stuff. I think both of these are well documented, big communities involved with them. And they're both free. There's free versions of both. I think the Unity has a pro version where you pay them so much, like if you want to make If you're going to make so much money, then you'd pay them. But otherwise, they're completely free. So unity3d.com/unity, and the andengine.org is a popular 2D engine, OpenGL game. Many Android games have been made with it, with both of them. Yep, and then the Wikipedia article on the list of game engines. That's not just Android, but all kinds of game engines. And then two sites for like what they call professional game developers. People have been doing it a while. Even before Android, they've been doing game development. Robotinvader.com is a guy named Chris Pruitt. He's worked for Google for a couple of years. And then he was in the game industry for about a decade before Google, so he knows about 10, 20 ship titles. He made the Replica Island. I don't know if you remember that, but it was made in 2010. I think it came out in 2010, and it was probably the best side scroller. It was classic side scroller, like in the style of Mario games out there. He since went from that, and he made the source code completely available. It's all done in OpenGL with his own engine. He wrote his own little engine for it. And then he created a company called Robot Invader with a couple other guys that do the graphics. He's the main programmer there. And he has a blog. He's an interesting guy, an interesting personality. I like his talks and stuff. He talks very quickly, so he assumes a lot of knowledge too. I mean, he's very intelligent, very up on the latest game stuff. When he talks, he assumes a lot of, do you understand him? You got to know a bit about game programming and the terminology. So he has at least 3 talks out there for Google. In 2009, when he was about to release Robot Invader, Replica Island 2010, when he released it. In 2011 is another talk about after it was released, talking about how to make massively compatible games or something like that. Talking about all you need to know to make it so your game would work on as many devices as possible. He studied that, and he has a lot of statistics and stuff. It's very scientific approach. Now, Wind Up Night is the game that Robot Invader created using Unity. I think they're using the Unity engine, so you can see what a professional game looks like. 1 and 2, I think both use the Unity engine. So, very nice looking games. They're both side scrollers, sort of a 3D, semi 2.5D side scroller. It's from an angle. This is the way the Wind Up Night looks. And the developer stories from developer.android.com/distribute/stories. You type in developer stories at Google, you'll find this site, and it interviews people like Chris Pruitt and a lot of other quote-unquote professional developers who have some really good games out there, and show you what that can look like on Android. So that's it. It's the end of my talk. Thank you.
Very sneaky, very sneaky, very sneaky.